Okay, we're going to take you down a couple of levels now to closer to the storage device layer. We're going to talk about a way to automate the process of mapping devices to your application automatically, and also get some new class of analytics data out of your devices. So not talking about data, talking about device level analytics here. So a couple of things we'll talk about. SDS challenges, software-defined storage is a term you'll hear coming up regularly. The need for a fast, efficient storage device layer. SDV, we call it here at Enmotus, and a behavioral analysis and automation of storage devices. We'll just touch on something, and I may even be able to show you something here a lot of you have probably not seen before, how storage devices actually behave under certain loads. So let's talk a little bit about the stack itself. We operate inside the server in this context of this discussion here. There's a lot of turbulence going on from a storage device perspective. Put yourself at that lower level for a second. You got hyperconverged storage. We've talked a lot about that today already. Scale-out storage systems, virtual data centers, operating systems, cloud. You've got at the bottom of that, there's a lot of three-letter acronyms down here. I'm sure many of you have not bothered or never really want to know about. And I think both in flash is the obvious one, where there's a lot of churn in the technology, hard disk drives, SMR, shingled recording, archive, even good old tapes. We've heard all this today, that there's still a lot of iteration going on, NVMe over fabric. So how do you normalize some of this? And also, how do you address some of the key issues that's starting to come out of all this diversity in systems and complexity as you scale out to large systems? Long-tail latency is a great example that some of you may be familiar with. How do you handle those kind of, those effects that are going on in your system? Device analytics, how do you get better data? Most of the systems at the top here see their storage devices as a file system. They don't see any further down than the file system itself. So what we're introducing here is a storage device virtualization layer. This is a very fast, very, very lightweight layer that sits right above the storage devices and essentially masks you from all that complexity underneath, so you can build virtually anything on top of it. Looks like a disk drive as far as people are concerned today, all the applications. And within each of those, within that layer, you now have access, as we'll show you in a second, to a lot more data about performance, analytics, and the ability to proactive or automatically manage. And you'll see in a second what we mean by that. And then secondly, the ability to manage this at scale. The ability to pull out data from hundreds of nodes, aggregate that data, and make better decisions on what's going on inside these large-scale compute and storage systems. So let me talk a little bit about storage device virtualization. It's an intelligent storage device software layer. It's a behavioral approach to mapping devices to application workloads. It's autonomous. It basically works in the server all on its own. And its ability to transfer data back gives you centralized device management back to a central server location, a device analytics server, and you get very fast translation. We're talking about sub-microsecond overhead in this kind of stack here, not your traditional virtualization layers. The benefits at node level, you get automatically load balanced data across RAM, SSDs, hard drives. System level, you're able to detect and isolate issues such as long-tail latency. And you get a central collector mechanism now to analyze and correct device behavior, hopefully before it happens, by using more behavioral techniques rather than the traditional smart log, IO stat, or just measuring data in a system. You're actually applying a lot more intelligence to it. And more importantly, we're developing a framework for some open APIs to provide by JSON RESTful the ability to build your own framework around these, for example, or bridge it to Splunk, something like that, if any of you are familiar with the Splunk system management tools. I'm not going to go down this list here, but there was a very interesting paper I've referenced. When you get a copy of these slides, you'll be able to see from Google. They did a disk for data centers. It was Lawrence Ying's paper. Caused a lot of discussion in the industry, but you'll see here that storage device virtualization has a very, very important role to play as a bridge technology. Rather than reinvent another hybrid device or special purpose device, most of these issues can be tackled in a software-defined layer sitting right above the storage devices themselves in a very transparent, automated fashion. So I'm going to show you a little brief intro to our tool here at Enmotus. Basically, gives you the ability to visualize, virtualize. Let's see if it will actually play for you. It may not. I guess it's deciding if it wants to, and it's not going to. Never mind. What you were supposed to have seen there was the ability for this is kind of a virtual disk map You get to see for the first time where your SSD lives in your virtual disk space. And more importantly, as you see the workloads come up here in, say, the middle of the disk, you're going to see, you would have seen this red section here relocate itself in real time. This is a real-time engine that will actually put the media under the data so you can actually get the benefit of going from a few hundred IOPS up to several thousands, tens of thousands, if not hundreds of thousands of IOPS, depending if you pulled in NVMe storage or not. This is fully automated and something that will self-load balance in every node in the system. Okay, thank you.